Dun-dun-dun, 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 Ohm's Law, Ohm's Law, yeah! So, before we begin Ohm's Law, there's a couple of concepts that I need to explain to you. The first one being voltage, or V. Now we can express this through water as the velocity coming out. As you can see, I've increased the speed so it comes out faster and faster. Think of this as voltage. Second thing is current. This can also be referred to as I. Now that essentially is the flow. Don't think about the speed coming out, but more the amount of water that is coming out of the hose right now. As you can see, it increases. The next concept that I need to explain to you is resistance, also known as R. As you can see, it determines by the diameter of it and also how much is allowed to flow through this kink. Now Ohm's law states simply that V is equal to I and R proportionally. It can also be expressed as inversely proportionate, like so. Allow us to visualize it in this example. As you can see, we have a low current or low flow of water, and because of that we don't have much pressure coming out of this hose, indicated by our small x. Now compare that to our large amount of current, or a large amount of flow. You can see a large amount of water is coming out, and therefore the pressure that's being exerted is much higher. Now let's move on to resistance. Here there is little to no resistance from this pipe, and as you can see, again we have such a low pressure, which is our voltage. Now when we transfer over to quite a small surface area or higher resistance, we get a very large pressure coming out that just allows the water to completely just shoot across. So let's put this into action. Let's say that our current, the flow, we're not going to change that at all, is constant. We're not going to move that. All we're going to do is increase our resistance, and we're going to watch how much further it goes forward, alright? Just going to put a kink in it, stops, and then it'll start to burst out and go a lot further. So I can feel the pressure building up within the hose, and if I were to release that, it just goes everywhere.